Another case would be where variables will have a maximum or a minimum. So when variables have a maximum or a minimum, over certain range, the relationship is positive, and over certain other range, the relationship could be negative. Let's consider two cases. The first case, over here, I have rainfall, a number of days of rain per month, and on the vertical axis I have the wheat yield in terms of bushels per acre, right? So when we have, say, 2 days of rainfall per month, the wheat yield would be so much, and as we have more number of days of rainfall, the wheat yield rises. So over this range, the relationship is positive and upward sloping. However, at 10, it maxes out, and that's when we'll have the maximum amount of wheat yield in terms of bushels per acre. When you have more rain, say you have 20 days of rain in a particular month, then you will get lesser wheat because there is one optimal point of rainfall that is needed to get the maximum amount of wheat yield in terms of bushels per acre, right? So in this range, over the first half, you have the upward sloping curve, but over the second part, you have a downward sloping curve or a negative relationship between the two variables. So here we have one point where there is a maximum. Let's consider the second case. In the second case, let's say we have speed in terms of miles per hour on the horizontal axis, and the cost of gasoline per month, right? So when you are just traveling at the speed of 35 miles per hour, this would be your gasoline cost per mile. As you drive faster, the gasoline cost keeps on falling, right? And when you should drive on highways, say at 55 miles per hour, that's when you will have the minimum cost of gasoline per mile. However, if you drive even faster at say 60s and the 70s, the cost again goes up, right? So over this range, there is a negative relationship, and then at 55 miles per hour, that it hits the minimum, and then again it starts to rise. So over this range, there is a positive relationship. So in this situation, we'll have a minimum point where you'll have the minimum cost of gasoline at 55 miles per hour in this example. Sometimes we want to emphasize that two variables are unrelated and does not affect one or the other. So let's say two situations. So on the horizontal axis, I have price of banana, and on the vertical axis, I have grades that you score in economic class, right? I mean, of course, you would expect that, well, there is no relationship between how much a banana costs and how much grade you will get in the economic scores. So in this situation, y is a constant, which is on vertical axis. You would get it 75% in economic class because the grades in economics depends on several other factors, definitely not the price of the banana, right? So here we have two variables which are unrelated, and the y is a constant. So y is on the vertical axis, right? Let's consider the second situation. On the horizontal axis, I have output of French wine. So how much does the French wine in the French vineyard is produced, and the amount of rainfall in Chicago. Well, of course, you would expect that there is absolutely no relationship between the two variables. Yes, of course, the two variables are unrelated. However, the way the setup is, in this case, we have x as a constant. The amount of production of a French wine is going to be a one fixed number. It does not depend on the amount of rainfall in Chicago. Correct? So the two variables are unrelated with an x being a constant.